We're going to talk a bit about serverless definitions. It's more like what are the characteristics, because every person puts serverless on a different definition. Like we do one way, other vendors does on another way. So we think that serverless, it's when you're able to focus on code and you don't need to worry about the infrastructure, because you can scale from 0 to whatever you need and scale back to 0, which is really important. So you can only pay what you use and not let those resources being wasted. But to do serverless, you usually need to do a stateless application. Why that? Because a stateless application doesn't store data, doesn't store the application state, and does not have a persistent storage. That means there is a, like Heroku, if you deploy a Rails application on there and you're using SQLite, you're gonna have a tough time because SQLite is a persistent storage on your desk and they throw an error if you do that. That's an example of how they work, a different vendor. So let's talk about servers. Who here think that may be true? It's serverless the new shared hosting? Because you have instances, you have requests per instances, but aren't you in the end sharing resources with other people? Okay, it's limited to you. You have the right to a certain amount of memory, but it wasn't that what shared hosting did too? So let's see. It works on my machine. Everybody ever said that? I don't know who haven't said that yet. And if you didn't say that, probably you still need to program a bit more and you will say that. So once it works on a machine, when you say that, I'm from the good old days where like servers had god names, Greek god names or Nordic god names, because people thought it was clever. So you named your server, you knew the server personally. You set up certificate, user management, and then uploaded your files via FTP, which is not a good idea. Or if you were a bit more command line friendly, you would use SCP. Now, if you saw Magento as a software before, it's a lot of files. And it takes a lot of time to upload that via FTP. And usually, some files don't go. So, beyond that, who here have heard about Subversion and CVS? Okay, CVS I think was created in 1991, and I used that in 2008. Yeah. So Git I think was coming, and Subversion was dominating it. But like still, all of these things were each machine you had to do a separate deployment because you don't had much automation. You had some batch scripts, but you needed to run that on each machine separately, and each machine had their own IP, and sometimes you had trouble because that IP got blocked by another API, and you didn't know why it doesn't work on that server. So that's one of the problems with that approach. The modern approach, it's what a friend of mine said, it could be considered the millennial versions of servers. So machines are commodity. Like you don't care the name of the machine, the IP address the machine is gonna have, as long as it follows a set of rules that you define, it's okay for you. And then we have tools like CI, continuous integration and continuous deployment, to help us deploy applications to those servers, because remember, we don't know what's the name of the server. It usually has a UUID on it. It's easier to scale horizontally, especially when you're using tools like Chef, Terraform, Puppet, Ansible. That makes the job a lot easy and less prone to errors. And don't forget, we have like containers, Kubernetes. It's like the top hot topic of the moment. So that's why I say that the modern approach, it's more as a commodity, not as a personalized approach to servers. So I have a couple questions for you. Is Kubernetes serverless? No. Kubernetes can have some serverless behavior if you're deploying stateless application, but with Knative, which is another project. And if you do that, you can scale to 0, but if you know the Kubernetes terminology, you can scale to 0 pods. The nodes, the machines you spin up, you cannot scale to 0. So if you follow the terminology of serverless where like you can actually scale back to 0, it's not serverless. Because you still pay for those nodes even though you're not using for them. So it's not. Should I use serverless for blockchain? No. There's some articles that says like the similarities between blockchain, but like I've stopped to think about it. Blockchain is a stateful thing. So how are you gonna manage that on a serverless architecture? I mean, I think you can subvert the use of any technology to do whatever you want, but doesn't mean it's gonna be easy or that you should be doing it. So not a good idea. So at Google Cloud, we have these 3 technologies for serverless. And I mean as a computing resources, because if you stop to think about BigQuery, for instance, when you just put your query there and you pay per use of scanning or your tables, not how much you're storing it or how long it's been running the BigQuery server, and it scales for you, it's kind of is serverless too, and it's a database, kind of. So those are computing resources that we have as serverless. And I'm going to explain each one of the 3 ones. Cloud Functions, it's like when you create a class, but even a smaller scale where it's single purpose. It's like you say single responsibility for each class. It's even lower than that. It's a single responsibility for each function that you're using. You shouldn't be creating full-blown APIs inside a function, or and from other vendors, Lambda, for instance. And those things are useful if you're trying to map events or triggers. Events in this case could be, oh, I uploaded a file to a bucket, and every time I upload a file to this bucket, I want this function to be executed. Or yet, I have a pub sub, which is our queuing system, and I want every time an event comes on pub sub, it triggers this function. So, and also HTTP requests a form of getting those events triggered. We support 3 platforms for that: Node.js on the versions 10, which is better, version 8, which is GA, and version 6 that's GA, however, is deprecated, along with Python 3 and Go 1.11, the most recent version of Go. If you're writing functions, the probability of the Go runtime being more up to date is higher than everything else at GCP, for instance. Use cases, as I said before, you can do your APIs in there, but like focus on the lightweight services. Like for instance, I uploaded an image. The image is too big. I want a thumbnail of that. Why don't you write a function that get the image that you wrote, uploaded, and then create a thumbnail using that function? So you don't have to have a server running just for doing that for you and using your own resources from your server to do that kind of stuff. So as I said, we have Node. We're writing JavaScript, you're probably going to use Node.js. If you're writing Python, we're probably going to use Flask, which is their lightweight framework. And if it's Go, it's just Go. We just use it. This is an example of the Cloud Functions panel. So there is tons of way for you to trigger. As I said before, you have here the trigger port where you set up HTTP, pub sub. If you use Firestore or Firebase events, you can also do that. You can allow people from outside to invoke your function, and the ways of adding the code to your function if you want to use the user interface. Those are the runtimes, and here, if you're using the online editor, it's what you add in there. For the Node.js example, It's literally 2 lines of code if you don't count the export. Then you say which function you want to execute, and the memory allocation varies from 256 to 2 gigabytes, if I recall correctly. The timeout of a function, it's 9 minutes. So everything that you run on a function, it's not made to run forever. It's not a cron job that can take hours to do. It's something that's going to run fast. And the time that when I started 2 years ago was 6 minutes, it increased to 9 minutes now. So you have 9 minutes to do whatever processing you're doing. So I have this demo here. It's a URL. I'll share the slides later, and you'll be able to see it. And I'm gonna do one thing using the Google APIs for machine learning, which it is, I'm gonna get this tweet that I tweeted yesterday or 2 days ago. And I'm gonna do a sentiment analysis, which just use APIs. I didn't have to do any machine learning to do that. And show you the results. So as I said before, here's the Cloud Functions console. And you can add I think it's 2 gigabytes. Yes, 2 gigabytes. 126, 1 gigabyte, 2 gigabytes. And once you do that, I created a function that gets a message as parameter, and that message is the status ID of a tweet. So you can get any status ID for any tweet and have a sentiment analysis going on. So in this case, it was positive, a score 0.5, and magnitude is like the intensity of that, how intense was that sentiment on that thing. It's a simple code, which I'm going to show you here. Sorry, my computer restarted. So actually, the code for that thing is the get sentiment here, the classify function. Because all of the other functions like get sentiment, get tweet, are there auxiliary functions that I use to make my code more separate. But like in the end, you get a request, you return if empty the request, or get the sentiment on it and return a JSON as a response for that. That's what you need to be doing to create a function using Python. So I'll be sharing the slides and you'll be able to use it. Again, that's the code that I showed there, just the parts that are important. So you'll be able to copy paste is not going to work because those functions doesn't exist here, but like to get the idea of how it works. Another one is App Engine Standard. App Engine, I used to say that's like a great product that's badly marketed. Like most people don't know the powerful thing the App Engine is. So you can, instead of deploying a function, you deploy a whole application on it. You can choose between 6 popular platforms, and you can scale again from 0 to a lot of machines that you need. And it's a fully managed solution where you don't need to worry about scalability, maintenance, software updates on your machine. It just happens for you. App Engine has a concept of services and versions. So when you deploy an application on App Engine, you create a service called default. It's the default one. But different services can have different versions, which allows you the possibility for you to think as services as environments. So you could have a dev environment, a staging environment, a production environment. And for each one of those environments, you can have different versions and serve those different versions to have an A/B testing, for instance. We don't have to create separate servers, deploy different services or different App Engine projects to do that. It's all on the same project. And the way you do the splitting of traffic, you can split traffic by IP, by 50-50, by a ratio that you determine, or randomly. So as I said before, App Engine can have multiple services, and in this example here, I have two. And I put it a dev. Dev has 3 versions, and the active version serving is the version C, while prod here is serving versions A and B to the final user. And you can create different, if you want, different URLs for it. And the timeout for App Engine, it's 1 minute. It's mostly the timeout of, like if you stop to think about PHP and other languages, that's the timeout, default timeout for an application. Runtimes. We have Node.js, Go, PHP 7.2, Java 11, Python 3, and Ruby is in beta, but it's version 2.5. Again, what I'm going to show you, it's basically the same thing as I showed before. It's the same thing with sentiment analyzing, but with a bit more information on it. So again, you put the status ID of the tweet, and it's going to return you the sentiment for the whole document, and then for each sentence that you have. This thing is made using App Engine deployed. I just created the code in Ruby. In this case, I use Ruby, not Python, and deployed there. And I'm going to show you how. So that's the application itself. It's a signature framework, micro-framework for Ruby. And you see here that you create a route, and you do your code simply, and the response in the end. So that's your application itself. You do that code, the only thing you need to do extra is to create a YAML file to deploy it, to tell which language you're using, which service is creating, and which version you're deploying. So when you deploy that, if you don't have any App Engine created, you need to use Google App Create, and then create your YAML file and just use the deploy. It takes 2 minutes at most. And the thing it does, it uploads your file on your folder to the server, and that server serves the entry point with the entry point you define here in the app YAML file. I don't recommend using Rackup and Ruby to serve production things, but it's just a demo. It was just a proof of concept here. Now, if you have multiple services, like the prod and dev, the only thing you add is the service variable and define if it is default and dev. By default, when you do a Google Cloud App deploy, you're going to deploy the app YAML file, but if you have multiple YAML files, you just add on the command line, and it's going to deploy all of those services for you. Again, you could have a branch connected to, you can have like a webhook on GitHub that sends to Cloud Build and deploy for you automatically on App Engine. You can automate everything that I'm talking about here. I'm just showing what are the steps if you want to try by yourself, and you're not going to automate things you're going to do only once. So that's an example. The only one is my favorite, it's Cloud Run. It's fully managed as Google App Engine can be, or Anthos. Anthos is our product for enterprise. It's basically when Cloud Run was launched in April this year, it was for GKE, which is Google Kubernetes Engine. But technically speaking, it's the same product, but you need to have an Anthos subscription service. However, you don't need to do that to run Cloud Run. You can use our own managed infrastructure. It's container-based and revision-based. So if you deploy a container and then you change the environment variables for that service, it's going to create a new revision, because revisions are immutable. So every time you do an alteration like machine size, how many instances I want the container to live for, that's a change that's going to create a new revision. I can scale to 0 or up this amount of requests, and usually the default is 80 instances. Spin up 80 instances until it creates the Docker file again. builds the Docker file, again, the image, the last image you deploy. And it can be up to 2 gigabytes of memory. For instance, if you're using Rails, you're going to use the 2 gigabytes of memory. There's no other way. Runtimes, anything that you can put on a Docker container, you can put on Cloud Run. You could create functions which we don't support on PHP, for instance, running on Cloud Run. You could have a binary that converts, let's say, docs to PDFs running there and create a service for that. And you get a conversion for binaries there. So you can do small things or bigger things. I have an application that's a bit political, so I'm not going to share. But it does run on Cloud Run, and I pay per month like $2. Like, I don't pay that much. So the cost is more effective because you only pay when you use, and differently from functions, a function only use one instance per request. So you cannot use the instance again if someone else do another request on your function. It's how it works. That's, if you're going to deploy a new service, you just need to say which is the container image URL and the region, or if it's going to run on CentOS, then it can run on the region that you define, the service name, and if you allow people from outside your network to do a request. And the optional settings is like, for instance, I wanna add Cloud SQL, which is our managed database, connection to it, so it can connect to the database, or environment variables where you can add to your Cloud Run build. So that's the same thing from there. Let me show you. Oh, I forgot to tell this. App Engine here, if you notice, V1.1 and V2, they are the same services but different versions. Running and being served. They're served in different URLs here, but like you can serve them on the same URL without worrying about it. In the created service, as I said, you have optional settings here, and we say the maximum request per container, the timeout, and the connections and environment variables. And if you run the same example, just change it from app to run, it's going to do the same thing as it did with the App Engine. The only difference between this application deployment and the other one, this one has a Docker file. That's the only difference. So this is the Docker file for this application. You just say which image you're using, which port you're going to expose. Don't worry about the run button config. It's just to freeze the gem file. And then you copy your files and say, hey, just run rackup at the end to put my HTTP server to run. It's like deploying locally. You actually can do your local development, push your image, and have that on Cloud Run without having to worry about that. And if you're lazy like me, you'd probably hate doing builds on your machine. I use a MacBook Air at home. So using Docker, it's not the ideal thing. So in the end, I ended up using Google Cloud Build, which I say, hey, tag this image as this one in here, and it gets the code that's on that folder that you're executing, and it sends to Google Cloud and runs the build and tags and pushes, and you don't need to worry about that. And in the end, when you're ready to deploy on Cloud Run, you just need to say, as I said, it's in beta. Again, which Google service is not in beta? And then you run deploy and the image, and that's it. You have your service running on Cloud Run. So how do you choose it? How do you decide what you're going to use? I'm showing you Google technologies. It's because I work there. And that's the only thing that I know how to use, honestly. I don't know how to use other vendors' technologies. So I was like, I cannot talk about it because, they're paying for my trip. I need to do my job. But how do you choose it? There are similar products everywhere. So you don't need to go buy these products, but you can get the idea. This is a bit complicated, but basically says, like, if you're building a stateless HTTP server, if you're using Kubernetes, customized, you need to use Cloud Run on Anthos. If you're using custom languages or system libraries or binaries, you can use Cloud Run itself. If not, if it's not a supported language, or you need Unity on your deployment, or it's based on driven by Cloud Firebase or Firebase events, that's the continuation of that. You use append or Cloud Function. So I'll share this on Twitter. Don't worry, you're going to be able to get it. That's the flow chart. It's not the same solution for everybody, but it kind of gives you an idea of what to use for which purpose. So again, that one is nice to take a picture because it has everything that I talked about on a summarized way. The languages you support, the only one that supports HTTP2, it's Cloud Run on Anthos. Normal Cloud Run doesn't do it. And the request timeouts for Cloud Run, I forgot to tell, it's 15 minutes. So if you have a longer process, you can be using Cloud Run to run that. So just to recap, concurrency requests, it's on Cloud Functions. It's more limited, so scalability, it's not the same as using Cloud Run and App Engine. They scale faster than functions because one request, one instance. And multiple requests per instance, those are the three technologies that you should be looking for. That's, I say, it's going to help you depending on your application deployment or whatever you're deploying. You can mix and match. You can use Cloud Run, Cloud App Engine, and Cloud Functions together. And I have an example here for you. It is supposed to have audio, but I'm not using the audio because the audio is not the important thing. So if you don't know, Google has a set of machine learning APIs. You don't need to know machine learning, but it can get a video and locate images on that video and show labels, as we say, and say, hey, this image appears on this minute. So, like, for instance, I'm going to get this one, and I'm going to say there is a wagon. Where does it appear? And it's going to load. Depends on the internet. Here. Let's see. Yeah. Okay, internet's not helping me. But the point is, when you're changing each pink thing or red thing here, it's where that keyword appears on your video. What is the architecture of that? Actually, it uses cloud storage, Google Cloud Functions, and App Engine. So I have the video content, and I want to upload that video to cloud storage because it's easier to get the API running from cloud storage. Then I create two processes. One to do generate a thumbnail, which you saw on the page, and I store that also in Google Cloud Storage. And the other one, it's a function to extract and transcode the audio from that, because there's also a transcription there. And then you put it on cloud storage, that audio, and run the recognition speech to show those images. So the difference here between the video and the speech, it's because the video is going to show the labels, and the speech is going to show the words that appeared on the video or audio. So to summarize everything that I said, on Cloud Functions, you do one thing. On App Engine, you do many things. And Cloud Run, you can do anything. That's what my colleagues said at Google Cloud Next, and that's what I had to you. Thank you.